In today's session of operating system, we'll move on to the next topic, which is nothing but inter-process communication. So now, in this inter-process of communication, in today's topic, we'll cover how we go for inter-process communication using pipes and using semaphores. Now, before entering into the detail of how the inter-process communication is done using process, what do you mean by inter-process communication? As if you want to pass the information from one particular person to the other person, we go for using some type of communication where we communicate in a language. Similarly, when multiple processes are being executing, they want to share some information. So, one process wants to give some information or take information the other process. In that case, we go for inter-process communication where the sharing of information can be done. And in this case, these two processes can be present on the same machine, or you can have a situation where the processes are not present on the same machine, they can be on different systems. So, even then also the message can be passed from one process to the other process. Now, why is the need for IPC or inter-process communication? As I told you, the first and foremost important thing is nothing but sharing of information, passing the data from one process to the other process, and speed. So, when you go for this particular speed, since you have multiple processes which are being working on a particular task and the information is being passed among them. For example, this particular process 2 requires the output from process 1. So, instead of making the computation at this particular stage, it can just make the work done by P1 to be used in this process, so that the speed of the process can be enhanced. The other one can be modularity. When for a given project, if it is very large, you go up dividing it into modules, and as you all know, when you have multiple modules, there is an interdependency between them. So, in that case also you want the information to be shared. And since you have multiple processes working on the same task, it is very easy for the user, so that the work can be done, as I told you, in less amount of time, and it is very convenient for the user because time taken would be less for the task. Coming to this advantages and disadvantages, I mean, when you go for this, what are the advantages and disadvantages of it? So, before that, we will just go for seeing what is a pipe, then come on to this. So, now the foremost important IPC or inter-process communication here can be done by means of a pipe. So, pipe is a name given here, where you can dump the data at one end of the pipe and retrieve the data from other end of the pipe, and these pipes are basically categorized as unnamed pipes and named pipes. Now, we will first go for the first particular thing where you have unnamed pipes. See here, this is the area where you dump your data, and one end of the pipe is used for writing the data, the other end of the pipe is used for reading the data. So, when you have, and this is basically used between a parent and a child process. So, when the parent is writing the data, the read end of the parent is disabled. Similarly, when the child process is reading the data, the write end of this particular child process is being disabled. So, it is basically used for communication between parent and child process. One will be writing the data, the other will be retrieving the data. Now, why we call it, when you go for the previous case, this is nothing but your unnamed pipes, as I told you. So, when you want to write the data and read the data, you require two file descriptors. We generally go for FD of 0, which is used for reading the data, and we have a file descriptor FD of 1, which is for writing of your data. So, these two file descriptors plays a major important role when you want to read or write the data. And the reason why you call it as unnamed pipes, unnamed pipes are also known as your traditional pipes. These are the initial pipes which were designed for passing the information, and you can even call them as anonymous pipes because no name is being provided to that particular pipe. Coming to the actual implementation of it, when you want to pass the information from a parent to a child here. So, as I told you, you require two file descriptors. So, we are declaring an array of size 2 where FD of 0 is for read and FD of 1 is for write. And you have a buffer where it will be used as a temporary storage location for putting up your data. Now, this particular condition, pipe of FD, is used for creating an unnamed pipe, and it gives, in turn gives two descriptors, one is FD of 0, the other is FD of 1. One can be used by the parent, other can be used by the child. So I have created a pipe, but you need to even go for creating the process. So how do we go for creating a process? P is equal to fork. So this particular fork command will create a child process. So now you have a parent process and you have a child process existing from that particular point. How do you identify whether it is a parent or a child? Depending upon this particular p value. If your p value is greater than 0, you designate that it as a parent, right? So if p is greater than 0, now this is your parent process and this is your child process. And you have two descriptors here, one is for read, the other is for write, and here for the child also you have a read and write. Now the parent wants to write. So what I have to do at the first thing, close of fd of 0 means that I am just closing my read part because I want to dump the data. So here you are writing that the parent is passing some value to the child. So how does it do? So that is done by your write command. So write which descriptor will be used, fd of 1, and what is that? So this is the name of your descriptor and this is the actual message you want to put it on the pipe and this is the size of your message. So by this you are putting up a data hello onto your pipe and this makes your parent to wait till when the child has to read the data. Right now if you are executing into your else part, so when does you go into your else part? If your PID value is not greater than 0, will come up to your else part where the child has to read the data. So when the child has to read the data, what is that it has to do? It has to close the write part because it has to only read. So first I am closing this write part, then you are just displaying that information that you are reading the data. So how you are reading the data? So what is the operation here? Read. Read, the descriptor for read is fd of 0. Now you are reading the data. Once you are reading the data from the buffer, what is that you are reading from the buffer? Pipe hello. So where that is to be stored? It is to be stored on a temporary location, that is nothing but your buffer. So hello will be stored here. So that indicates for the storage and this 100 indicates the maximum capacity. And this is nothing but now it is nothing but write of 1 comma buffer comma n, which is nothing but you are just displaying the values of the buffer onto the screen. So this indicates how the data is being passed from a child to a parent or a parent to a child. Now this is nothing but that is about your unnamed pipes. Now we want to go for using Fifo. The other particular pipe, you have two pipes here as I told you. This Fifo is nothing but your named pipe. And when you go for your named pipe here, instead of creating a buffer as we have seen in the earlier case, what you do is we just go for creating a file and that particular file will be used both by your parent or your child, or we can even call it as a sender and a receiver. So here we just give a name to that particular file, that is the reason we call it as a named pipe. So for that, first of all you need to create a named pipe, you have to give a name to that particular pipe. The process or the sender process will dump the data and the receiver process will receive the data. Now how do you actually create a named pipe? So these are the header files which are normally required, and here you concentrate on it. MKFIFO means that you are making a Fifo pipe, means that you are creating a pipe and this is the name of the pipe. So as I told you, it is a named pipe, this is a name given to it and these are nothing but the permissions which you are giving. So here the 0 indicates that it is an octal number and the remaining values here indicates that what are the permissions you can give it to your owner, group or to the user who is using it. And finally this indicates that you have created your pipe. So the first task is done, you have created a pipe. Now coming to the next one. So now you have a file created, you have to dump the data. So who has to dump the data? The sender process. Now coming to your sender process, the sender process will open a file. And what is the name of the file which I have given? Fifo1, because I have created using the same name. And in which mode I need to go for using? Write only mode, because the sender process wants to write the data. And you already know the syntax of your write. What is that you want? This is a pointer related to that particular file. This is what I want to write it in the file and this is the size of that particular data what you want to do. So you are just writing, the sender process is generating or sending the data and you are just displaying the ID of that particular process, because here we are dealing with parent and child process. Now the third task here is nothing but receiver. I have created a pipe, the sender has put the data, now the task is the receiver has to receive the data, right? Now when the receiver has to receive the data, again the receiver will open up a file and see here the same file name I am using, and in which mode we are going for read only mode. Now I want to read the data from which pointer res, and whatever data you are reading, it is being stored in your buffer, and this indicates the number of characters that are being read. So this displays the data is being received by the receiver. So when you want to execute these three programs, the first one you will be compiling and executing it, whereas when you go for it, you compile both the process individually and try to execute them in a combined way, so that you will get the output sent from the sender to your receiver. Now having seen the process of your pipes, you understood how the data is being sent, whether it is a named pipe or an unnamed pipe. What are the advantages and disadvantages of it? It is very simple. Why? Because you are just creating a file or a buffer and putting up the data, and it is efficient, indicating that there is a surety that the data is being received by the receiver, and it is very reliable because you are only using a transmission medium for transferring your data, and flexible. You can implement this in any of your protocols, whether it is one direction or two direction. Coming to your disadvantages, it has a limited capacity, meaning that it depends upon the buffer size when I go for unnamed thing, and it is unidirectional. Unnamed pipes are unidirectional, so one is sending, the other cannot receive the data at the same time. And here you want to implement synchronization, because when one process is writing the data, the other process cannot read it at the same time, and you have a limited scalability, indicating that the number of processes that are to be included in the communication process. Now we have seen what is a named pipe and unnamed pipe and all those things, but coming to the basic differences, named pipe you generally use between two processes and a name will not be provided, whereas here you are creating a file for passing the information. This is unidirectional, where it can be bidirectional, where you can send it. Here it is only between two processes, whereas in named pipe you can go for multiple processes. Coming on to the next one, as you have seen, interprocess communication is nothing but the communication or passing of information between the two. So in that case also you want some synchronization to be achieved, right? So even we go for semaphores here, which we have dealt clearly in the remaining classes, but here we only concentrate on the operations which are basically required. So here we have an operation which is nothing but semget, which is used to get the identifier of a semaphore. So for that, concentrate on this. Semget is your function. This is nothing but the ID of that particular semaphore and the number of semaphores you want to use it, and these are your predefined flags which we can use it while getting the ID of the semaphore. So when I execute this particular function, this will give me an ID of the semaphore if it is successful, otherwise it will return a value -1. So semget is used for creating a semaphore, and the ID of the semaphore will be stored in the return value. Now I have created a semaphore. Next you have to control that particular semaphore. So when you want to control the semaphore, the function here is semctl, which stands for sem control. This is the ID of the semaphore which you got it as output from your semget, and this indicates the number of semaphores you want to operate. So if you want only one semaphore, the value of it will be 1, and the type of the command you want to give it. So these are the different types of commands you can give it. You can get the status of it, you can set the status of it, you can remove the semaphore ID, you can get the value of the semaphore, you can even get the PID of the semaphore of the process which is using this particular semaphore. So that all comes under your third argument, depending upon the value you are using. So here you can even have a set value. So depending on that we go for using the fourth argument here, otherwise this particular fourth argument is optional. So the result of this is it provides you the output depending upon the control operation you are doing, otherwise it returns a -1, indicating that there is an error in the function. Coming to the third operation here, which is nothing but semop. So sem operation is used for, now normally for what purpose I am using a semaphore? For locking or unlocking before you enter into a critical section. So that operation is to be done, right? So for that we go for using semid, which is you are getting from semget, as I told you. Here we have a structure known as sembuff. You need not declare a structure, it is a predefined structure which is very much available, and here I only pass the address of that particular structure, and this indicates the number of operations you want to perform on a semaphore or the number of elements that are present in an array. So this is just an integer value. Now coming to this struct sembuff, we'll see what are all the variables that are being declared in a sembuff. So this is your sem number. So it is nothing but it is an ID given to the semaphores. So now if I have two semaphores, then the ID of your first semaphore is 0, the second semaphore would be 1. If I go for only one particular semaphore, the ID of the semaphore will be 0. The next one is your sem operation, which indicates the type of operation, and it is an integer value which can be either -1 or 1. -1 indicates this is a lock and 1 indicates that you can go for unlock. And when you go for sem flag will indicate the type of operations, and if you don't want any of the operation, you can just give it as 0. Otherwise, you go for including sem undo or IPC no wait, depending upon the operation you want to do it. On successful, this returns a 0 value if the operation is successful, otherwise it returns you -1. Now we will just see a sample example including of all these operations. Now we are going for semget, indicating that I want to create a semaphore. So this is nothing but this particular instruction will tell you that if the semaphore is not existing, you go for creating it. And how many semaphores you want to create? Only one. As I told you, these are nothing but the permissions you are giving to the owner, to a group or a user. And this 0 indicates your octal, and if I am only going for a value 6, it is nothing but you only have read and write permission. So if the semaphore is not existing, you go for creating a semaphore, and the ID of the semaphore will be present in a variable semaphore. And I am just declaring a structure, predefined structure which is available. So if semaphore value is less than 0, means that the semaphore is not created, so it ends up here. Otherwise, it comes to this particular statement indicating that the semaphore value is created, and see here the number of semaphore, sem number, I want only one particular semaphore, so the ID of it is 0, and this is your semaphore operation as I told you. -1 indicating that you are locking the semaphore, and sem flag I don't want either IPC wait or sem return, so here we go for only no IPC wait, so I only go for sem flag. Now coming to this operation semop, what is the first one you go for passing it? ID of the semaphore. This is nothing but the address of this structure, and this indicates the number of operations you want to perform on a semaphore. If it is not successful, it will just display you that it has failed to lock. Otherwise, it tells you that the semaphore is locked and you enter into a critical section, and now you are into your critical section. After coming out of the critical section, I have to unlock it, right? So for unlocking, I will make the operation as 1. Now, if this unlocking is not done properly, then you get that failed to unlock, otherwise you get the output as semaphore unlocked. So you are able to create a semaphore, lock a semaphore or unlock a semaphore. Now you want to control your semaphore. If you want to control your semaphore, this is the ID of your semaphore, and this 0 indicates the ID of the semaphore because it is only one semaphore which is there, and IPC RMID means that you remove that particular semaphore because that is no longer required. So if you are not able to remove the semaphore, you get this error, otherwise you get it as semaphore removed. If the program executes successfully without any failure case, you get the output as semaphore created successfully, you have locked the semaphore, entered into the critical section, you are able to unlock the semaphore, and finally remove the semaphore which you have created. So these are the two techniques. One is your unnamed pipes, named pipes, and the third one is your semaphores. We will continue with the next classes in the next thing.